Is it possible to realize continuous driving even without change of machine and lining design?
This is called thrust shell, TSS, thrust shell. You can stop for 3 minutes.
Only 3 minutes.
Full continuous operation in a single shield.
So, Jianguo, in your last episode, you have introduced the helical lining design patent. However, it needed to design the lining specifically for your concept. Is it possible to realize continuous driving even without change of machine and lining design?
It's possible, as we discussed before, the helical lining is a completely new concept, a completely new segment design. We realized that acceptance of the new concept could be difficult by the engineers and owners.
Yes.
Maybe do an intermediate step. Again, my partner, my friend Behzad and I, we came up with the new concept. This is called thrust shell, TSS, thrust shell. The concept here is that we are using the space behind the segment and interior of the shield, that a small space, to create this shell which can transfer the load from the machine to the last set of segments. So when we can transfer the load, there is a space that is created so we can build the ring as the machine is moving forward. So with a single shield, there is no need to stop per se for segment building. The machine can continue going forward and we can build the ring and just stop a short period to extrude the segments from this thrust shell. So this is the general schematic of the thrust shell. It connects to the thrust cylinders in the machine, and then it is a shell, so it transfers the load over to the last ring, as I will show you. And this, the section here essentially allows us to make that transition and then collapse it, move it forward, and extrude the segments. So in terms of timing, a typical excavation is about 30 minutes. And ring build, again, is about 30 minutes. With this system, as you excavate 30 minutes, you can stop for 3 minutes.
Only 3 minutes.
Only 3 minutes, extrude the segments and continue. So it shortens the cycle a lot. And also, again, it allows for fairly close to continuous operations. As we go forward, we can actually see the segments we are using are identical, no change. The segments that we are using today, the same thing. The machine is also identical. What we need to do is at the tail shield, maybe extend it a short length and fit in the thrust shell in the back end of the machine. Again, seals are identical, segments are identical, so we can actually build the same ring and go forward. It sits between the last segments, and this is the tail seal, the existing segments, and the machine. So this shell is the blue section that allows us to have the space to build the next ring as the machine is moving forward. So essentially it bypasses this section, transfers the load over to the existing last ring. Everything else is identical, so it makes it a lot easier to adopt. So there was a discussion that maybe in the time of transition, you need to transfer the load over to the last segment. There are a few alternatives we can use. This is one of them, to transfer the load, while the last collapsible transition part can actually be moved forward, and we need to maintain this area and transfer the face pressure over to the segment. So these are some schematics of possible scenarios, step by step. So essentially this is the machine ready to go for the next segment. The thrust cylinders bypass the system for ring build with this thrust shell and transfer the load over to this segment, right? So this area is open we can build a ring, as you can see. When the ring is complete, that last piece can collapse, and it now is ready to extrude the segment that is already being built. That's the 3-minute time I told you. So these red cylinders essentially extrude this last segments. You can connect it, right? And these expandable part is then moved forward and it's getting ready to really reset and continue for the next round. We also have had provisions for making turns. So all of the requirements for using the existing segments have already been built in. And in this case also we are waiting for a full-scale test. And we had a machine lined up, a 4.5 meter diameter machine to do a full-scale test, waiting for a contractor funding to actually make it happen and deal with all the forces and essentially some intricacies relative to movements of the segments and applying the entire system. So it's pretty much ready to go. We have talked to some manufacturers. They're fairly positive about this. And I hope to see this as an intermediate section to go to a full continuous operation in single shield.
As you know, the continuous driving actually in the TBM industry first realized in the hard rock tunneling because the rock can support this lateral force. And now you have proposed 2 scenarios, and the first one is you already introduced helical, and this one also. And I would like to tell you, in China, like STEC, they also develop their system. They use the surplus capacity of hydraulic jacks to realize partial, not full continuous driving. I would like to invite them to introduce their technology next time. Yeah, thank you very much for your interesting introduction.
Yeah, on this one as well, we have international patents and some patent pending in different countries, including the one we are working with you for China.
Yes.
So
yeah, I hope to see this application in China as well. 好了，今天我们的白云说隧节目就播放到这里，让我们再次感谢罗斯塔米教授的精彩演讲。我们期待大家继续关注我们的白云说隧节目，让我们下次再见。